Hey guys, so we are going through the mock exam. Please do not look at this until you have at least spent the 25 minutes trying question 1 and 15 minutes trying question 2. For question 1, so we are being given a table of f prime values, and it says the conditions of mean value theorem are met on the interval. Hold on, Lizzie's playing with something. Lizzie, stop. On the interval 0 to 3. So mean value theorem tells me if f prime in this case is differentiable, which it says it is, then we would be looking at f of b minus f of a over b minus a. And we're doing it for f prime because it says for f prime. So we use our table. F prime of 3 is 4 minus f prime of 0 is negative 1 over 3. So then add that, you get 5 over 3. Now this one, it says the mean value theorem is satisfied at c equals 1. So find what this is. Well, if this is my average rate of change, and the whole point of the mean value theorem is there is some c value where the mean value theorem is satisfied, then this is going to be that second derivative at c. Now, I only know that c was 1 because it told me. What mean value theorem tells me is that, okay, if this is my average rate of change, then somewhere in here we must have a second derivative, because derivative of f prime is f double prime. So then, sorry, she's a bad cat. This is the point where it must be true. So this is all it is asking for in part A. For part B, it says use a right Riemann sum with 3 intervals to approximate this. So I have f prime. I'm going to do Riemann sum. Right means use the right value. This is a base of 2. Use the right value 4, base of 1. Use the right value of 7, base of 2. That's not 2. And then that's your answer. If you simplify it, you get 20, but we're not trying to simplify all of our answers. We're just trying to answer as much as we can, so I wouldn't take the time to do it. It asked if this is an over-under approximation. We know that, so I'm going to say because f prime is, and it tells me in the problem that f prime is, does it tell me? Oh yeah, f prime is increasing. So if f prime is increasing, you can go to your mega packet, or maybe to save time, it's actually faster to just draw an increasing function and then say, okay, between these 2 points, I'm using the right one as my height, so then this is an overestimate because f prime is increasing. C, we're asked to find this. I can take antiderivative of f double prime, no problem. That's just going to be f prime. But because there is an inside function, we need to use our u substitution. So u is 2x minus 1, du is 2 dx. So then du over 2 is dx. So now I'm going to rewrite this. Still f double prime, but the 2x minus u, I'm going to say, 2x minus 1, that's just u. And then dx, we just said dx is du over 2. I do need to find my new bounds, so this is, I need to find what u of 3 and u of 2 is. So I just plug in 2 times 3 minus 1, 6 minus 1 is 5, 2 times 2 minus 1, 4 minus 1 is 3, so 3 and 5, because 2 became 3 and 3 became 5, like this. And rewrite this. Dividing by 2 is just a coefficient of 1/2, f double prime of u du, from 3 to 5. And my handwriting was always kind of bad, and it's gotten worse because I'm not writing regularly. And then half is the coefficient that stays there. The antiderivative of f double prime is f prime of u, and it's evaluated from 3 to 5, which means plug in at 5 minus plug it in at 3. Make sure you keep that coefficient. Either write it on each term, or you could have it out front with like brackets. And I'm not done yet. I need to actually plug in what these are. So you just go to your table. F prime of 5 is 7. And then f prime, that's a 3. F prime of 3 is 4. Now, of course, you can simplify, but you don't have to. If you simplify, you get 3 over 2, I think. Yeah. But again, saving time, you don't need to do that. So part C, or D, it says that this limit right here, we know that we can evaluate it using L'Hopital's. Okay, we know that we can use L'Hopital's to evaluate it, so I'm going to go ahead and say, okay, if L'Hopital's can be used, this is the same as the limit as x approaches 0 of the derivative. So 4 is just a coefficient, stays there. Derivative of e to the something is e to the something. But then you need to multiply by derivative of the inside, so derivative of minus 2 of f would be times negative 2 f prime of x. Minus derivative of f double prime is f triple prime x squared times 2x. And derivative of the bottom is just f double prime of x. Derivative of 1 is 0. So now I have my L'Hopital's, because I've done this limit is just equal to derivative over derivative. And then now I just plug in, so this is 4 e to the 6 minus 2 times f of 0 times negative 2 f prime of 0 minus f triple prime of 0 times 2 times 0 over f double prime of 0. So this is getting multiplied, this last term is getting multiplied by 0, so I'm just going to ignore it for right now. F prime of 0 I have in the table. F prime of 0 is negative 1. So this is times negative 2 times negative 1. Oh man, struggling right now with this technology. 4 e to the 6 minus 2 times f of 0 was given to me. This is times 3. So this is e to the 0, which just becomes 1. So you can actually leave it like this, but if you wanted to, that's negative 2 times negative 1 becomes positive 2, and then times 4, so it becomes positive 8. But you don't have to simplify. Now the bottom, the f double prime of 0, that's the part that we don't have right now. And I can't get it from my table, right? It gave me f prime. I could approximate maybe, but that's not the same thing as finding f double prime. And it didn't give it to me in the stem. So let's think about, we actually know from the beginning that because it told me L'Hopital's rule applies, I know each of these is going to, each limit is going to equal 0. So the top limit, the limit as x goes to 0 of 4 e to the 6 minus 2, f of 0 is just 3, we just said it right there, minus f double prime of 0. I know, oops, I guess that's not a limit anymore when I plug in 0. I know this is equal to 0. This is e to the 0, which is just 1, so 4 minus f double prime of 0 equals 0. So that means that f double prime of 0 equals 4, so then f double prime of 0 is 4. Your answer is, of course, 8 over 2 becomes, 8 over 4 becomes 2, but I just left it like that. Okay. Again, for something like that, even if you don't get every single point, that's okay. Getting this right here is going to be at least 1 point. Usually these are like 3-point questions. Maybe this would be a point, finding f double prime of 0 would be a point, and then your final answer would be the point. E, it gave me a function, and I'm trying to find the derivative of that function. Okay, so here I've got quotient, so I'm going to use quotient rule. Low, d high would be f prime minus high, d low would just be times 2, underneath the low squared goes, and now I just need to plug in at 0. Oops. Always write it in terms of your derivative in terms of x and then plug in, so this will be 2 times 0 plus 5. F prime of 0 is negative 1 minus f of 0 is 3. 2 times 0 plus 5 squared. Make sure that looks like a times. You can, of course, simplify, but you do not have to, especially if you are struggling on time. If you do simplify, you get negative 11 over 25, but again, not necessary, and you might be spending time that you need for part F or to be checking your work. Okay, and last part of part 1 is F. We've got a differential equation, so dy dx is 3 minus 2y f double prime of x, and we have an initial condition, h1 of 0, which is like our x and y, 0.01, and we're asked to find h of x and then use that to find h of 2. So let's just start with finding h of x. This is a differential equation we're trying to solve. So this is our separate, integrate, what is he? Okay, let's move our dx up. So I'm going to move this guy up, and I'm going to move this guy over by dividing. So this will become dy, divide that whole 3 minus 2y term over, leave the f double prime of x, but multiply the dx. I've got 1 point now just for separating variables. Next step, take the integral of both sides. Antiderivative of f double prime is f prime of x plus c. The antiderivative here, we have 1 over with just a power of 1, right? It's not like 1 over y squared. So I am going to do natural log, so it should be natural log 3 minus 2y. But it is not just this. So think about if I have 1 over 3 minus 2y dy. You use u substitution, so u is 3 minus 2y, du would be negative 2 dy, so divide the negative 2 over, so this would be 1 over u, negative 1 over 2 du, so then this is just a negative 1/2 when you take the antiderivative natural log of u, which is what this is, right? I put the u back in, but there's a negative 1/2 out front. And now we plug in to find c. We have the point 0, 1, so this is negative 1/2, not 3. 3 minus 2 times 1 equals f prime of 0 plus c. Oops, I know what f prime of 0 is, that's in my table. F prime of 0 is negative 1, and then this is natural log of 3 minus 2, which is 1, and natural log of 1 is just 0, so this is 0. So then add 1 over to get c. Put back in my equation. I'm just replacing c is just 1. Now a bunch of algebra to get y by itself, so let's get rid of this 1/2 by multiplying everything by negative 2. So negative 2 f prime of x minus 2. Multiply everything by negative 2. You could also have negative 2 parentheses. It doesn't matter. Now I have natural log, so I'm going to do e on both sides. This is 3 minus 2y equals e to the negative 2 f prime of x minus 2. Let's subtract the 3 over, and then divide by negative 2. And there's your answer. Of course, you can clean it up a little bit, but I'm just going to leave it like that because why would I spend time doing this? This is my y, or my h of x. To find h of 2, I'm just going to literally plug in at x equals 2. Ooh, that's a 2. And then now, oops, that's a negative 2. And then now I just need to plug in f prime of 2, which is 1. Do not worry about simplifying. There's your answer. All right, hopefully you guys did well. And if not, you can, of course, just learn from your mistakes.